All right, here is video number 4 on radicals and rational exponents. Okay, so I've already filled in this top part here, perfect squares, perfect cubes, perfect fourths. This is a reference for you guys, so if you see these numbers coming up in different types of radicals, these are the factors that you're going to be looking for to split these up, okay? So here we are going to simplify radicals, and when we simplify radicals, what we want to do is we want to make a list of factors for the radicand, and the radicand is the number under the radical, okay? And we're looking for factors that are either perfect squares, perfect cubes, or perfect fourths, depending on what type of radical it is. Okay, because those numbers can be pulled out of the radical to simplify it. Okay, and I'll show you what I mean by that. So let's look at number 2 and number 3, and then we'll do a couple more examples here. Okay, so here we're just looking at this radicand here. We want to find the factors of 128 that are perfect cubes. Okay, and to save on time, I'll tell you that we have 64 times 2. Those are factors of 128, and 64 is on our list of perfect cubes. Okay, so we'll leave this -5 out front. Then we can split this up by saying this is the same as 64 times 2, right? And because of our radical rules, we know that we can split this apart. So we'll keep the -5 out here. We'll have the cubed root of 64 times the cubed root of 2. And then we'll simplify this. This can be simplified to 4. And then so we'll have -5 times 4 times the cubed root of 2. Then we'll just combine these like terms, -20 cubed root 2. That is simplified. 2 is not a perfect cube, so it's going to stay under that radical like that. Okay, and let's look at number 3 here. So same deal, except now we're dealing with the 4th root. So we're looking on our list of perfect fourths, and here we see 16 is on that list, so 48 is equal to 16 times 3. Okay, so then we can say 2 times the 4th root of 16 times the 4th root of 3. We'll simplify this down. 2 times the 4th root of 3. We'll just multiply these together, so we have 4 times the 4th root of 3. And there is your final answer. Okay, so as you can see, I've done pretty simple ones here. They get a little bit more complicated, but they still follow the same basic principle. Actually, I'll do number 4 for you so you can see what it looks like with variables. Okay, so 121 is actually a perfect square, and this is a square root. So 121 is the square root of 121 is 11. So we can actually pull this out. So first, let's separate it by square root of 121 times the square root of x to the 5th, y to the 6th. Okay, the square root of 121 can be written as 11 times the square root of x to the 5th times the square root of y to the 6th. Okay, and the way that we can work with these variables is just remembering that anything that we can have in the parentheses raised to the 2 is a perfect square. Okay, so if we have x squared raised to the 2, that's x to the 4th. This is a perfect square. If you take the square root of this, you'll get x squared. Okay, so what we can do is we can pull x to the 4th out of this and take the square root of that and move it out in front of the radicand. So we can have 11 times x squared times the square root of x, and then y to the 6 is actually equal to y cubed squared, right? So if we take the square root of this, the square root of y to the 6th is actually equal to y cubed. So this can be written as y cubed. So this, and this are all outside of the radical, so we can move those all up front. 11x squared y cubed, and then we're just left with the square root of x there. Okay, so really any even exponent on a variable can be pulled out. And if you have an odd exponent, you're just going to leave one of those variables under the radical and then pull the rest of them out. Basically divide the exponent by 2, and that's what your number will be outside. Okay? Adding and subtracting, you can only add and subtract. You're looking for like radicands. Okay, so to add and subtract, you need to simplify the radical so that you have the same radicand on both of your terms. So we'll do number 7 as an example here. Okay, let's simplify first. These are square roots. 32 is 16 times 2. 16 is the square root. So we can say -5 times the square root of 16 times the square root of 2, which can be simplified. And 18 is has a factor of 9, which we can pull out. So we'll say 7 square root of 9 times the square root of 2. Simplifying this becomes 4, and this becomes 3. So we have -5 times 4 times the square root of 2 plus 7 times 3 times the square root of 2. Combining these coefficients out front, -20 root 2 plus 21 root 2. Now we have the same radicand here. Okay, once we have the same radicand, adding and subtracting becomes really easy. All you do is add or subtract the coefficients. We have -20 plus 21, that equals +1. So we're going to actually be left with, we're not going to write out the +1 because it's being multiplied by root 2. So we'll just write root 2 there. That's a 2, not a z. Okay, so there's that example. The rest of these might get more complicated, but really you need to master this simplifying first, and then most of these you'll find like radicands that you can just add and subtract the coefficients for. When it comes to multiplying radicals, what you are going to do is you're actually going to multiply the radicands. Okay, so for this first one, and you're also going to be multiplying the coefficients. So you can kind of think of these as similar to variables with coefficients. So with variables with coefficients that you're going to be multiplying together, you multiply together the coefficients as well as the variables, okay? So here our coefficients are -1 and 2, so we'll multiply those together, we get -2. And then we multiply what's under the radicands together, which is going to be 360 in this case. And then we're going to simplify. 360 is 36 times 10. So we have -2 times the square root of 36 times the square root of 10. This can be simplified to 6. So -2 times 6 times root 10 is equal to -12 root 10. And that is how you do that. So you're always going to want to give your answer in the most simplified radical. Okay, moving on to dividing.